All right, a 5.34 kilogram piece of rock can be supported with a force of 40.4 newtons when submerged in water with a density of, so it must be slightly salty, right? What is the density of the rock? I don't know. All right, well, okay, so hold on. The density of the rock is going to be the mass of the rock divided by the volume of the rock. Yep. Okay. And we already know the mass of the rock, right? We know that that is 5.34 kilograms. All we have to do is figure out the volume of the rock. How do we do that? Well, I think we can do that by figuring out the buoyant force, right? Yeah. So here's this rock under the surface, and we're going to exert some force. We're exerting 40.4 newtons, right? Well, that 40.4 newtons is going to equal, what is it? It's going to be the weight of the rock minus the buoyant force, right? Because the buoyant force is going to act up. But of course it's a rock, so there's going to be a weight that's bigger than that, right? Okay. So how do we figure this out? I guess we can figure out the weight, right? The weight of the rock is mg, right? So that's 5.34 times 9.81. All right, let's do that. 5.34 times 9.81. That's 52.3854. Newtons. All right, now we're getting closer, right? 40.4 is equal to the weight, which is 52.3854 minus B, right? Okay, so if I just subtract 40.4, the buoyant force must be 11.9854 newtons. Now we're cooking with gas, right? Now we know what the buoyant force is acting on this thing. We know that that also equals the density of the fluid, right? Times the volume of the fluid displaced times G, right? Isn't the volume of the fluid displaced the same as the volume of the rock? Because the rock is underwater. So now we can find that volume of the fluid displaced, right? So this equals our density. So that equals the density of the fluid is 1008. And then 9.81, right? So I'm going to take this number, divide by 1008, divide by 9.81. And I've got the volume of the fluid, which is the same as the volume of the rock, is equal to 0.0012120.569. That's a 2. It tried to be something else, but there it is. And that's cubic meters, right? So now, ta-da, we are all ready, okay? So the density of the rock is the mass of the rock, which is 5.34 kilograms, divided by this really small volume, right? 0.0012120.569, et cetera, right? So 5.34 divided by that is 4405.7. That's kilograms per cubic meter. That's kind of fun, right? I don't know. It's like never give up. You can do it, right? Okay, so again, what we did, basically, it's just mass over volume. The mass was given to you. You just had to figure out the volume. So you had to figure out the volume from what, I guess, the difference between the weight and the buoyant force. That's the buoyant force. And then use the formula for buoyant force to find the volume. Right? All right.